Hello everyone. In today's revision video, we will discuss about indefinite integration, important formulas, and we will do revision for perspective of Jee Mains Jee Advance and MSc and other competitive exams. And one more thing that in this, if I ignore the term writing dx, then you consider term dx written in the question. And other thing is that if spelling mistake is there, then please ignore the spelling mistake. I am extremely sorry for the spelling mistake. Mm, so the first one, first formula is the formula of that if you want to integrate x raised to the power m dx, then the integration of this will be x raised to the power m plus 1 divided by m plus 1. Please note that in differentiation we multiply the power as it is, but in integration we divide the power by adding 1. And in integration, one constant is also added. In indefinite integration, constant is added. Definite integration, it is not added. Then integration of trigonometric function, integration of cos of x is sin x. Then please note that integration of cos x is sin x, and integration of sin x is minus cos of x. Basically integration is when we differentiate a function and then we integrate it, we get the original function back. Suppose there is a function f dash x, I'm sorry, if suppose there is a function fx, if we differentiate we get f dash x, and if we integrate we get fx. Other function is secant square x. You have seen that differentiation of tan x is secant square x, so integration of secant square x is tan x. I will come to the integration of tan x. Now other is integration of cos x square dx. Its integration is minus cot x, and you will see that integration of differentiation of cot x is minus cos x square x. Then integration of secant x into tan x is secant x. uh, then integration of cosec x into cot x is minus cosec x. Then see here, the differentiation of cosec is minus cosec x cot x. Sec x differentiation is secant x into tan x. Now see, if e raised to the power x is such a beautiful function that if you differentiate that function you will get e raised to the power x. If you integrate that function you will get e raised to the power x. One more thing I want to tell you, that if a function is that suppose you want to integrate e raised to the power 5x, then the answer would be e raised to the answer would be like this. Suppose you want to integrate, you want to do integration of e raised to the power 5x, then this integration would be as it is e raised to the power 5x, but the differentiation of this term will come in the division of the function, that is 5. uh, Other example I will give is other quite simple example, that differentiation of e raised to the power x, integration of e raised to the power x square, then it will come like e raised to the power x square divided by 2x. This is the simple. mm, Moving on, uh, the another most important uh, another most important this is that if you integrate, this is the most important term, this term, it is most commonly wide, is that integration of 1 upon x is ln of x. And all in this video I will talk, if I use ln, if I use log, all that is with is base e. If I use log also, it is with base e. Then another important different another important integration is that integration of 1 upon 1 plus x square is equal to tan inverse x or minus cot inverse x. see, the differentiation of tan inverse or cot inverse is 1 upon 1 plus x square. uh, Then another is that this from here the trigonom inverse, see this from here inverse integration has started. Then integration of 1 upon root of 1 minus x square is sine inverse x or minus cos inverse x. Then integration of 1 upon x times root x square minus 1 is secant inverse x or minus cosec inverse x. Now here is just that if you do this, I told before also that if you integrate a function which is already differentiated, then original function will come back. See here, if you integrate f dash ax plus b, then you will integration will be the original function. See here, there is ax plus b, so integration of that function, that is this part, and differentiation of this part divided by a. If the function, if the it is not directly x, it is suppose ax x square plus 1 and other functions. This is quite mostly used. You can do this by the formula of that cos 2x formula. You can do by that method also. Many times it is helpful if you just remember it. And one more thing, that here it is not cos, it is sine 2x. It is not cos 2x, it is sine 2x. And if cos square x comes, then just write cos square x is equal to 1 minus sine square x. Then this rule is quite if you understand this rule is easy. This rule is used if the functions are quite complicated, and actually this is for further. I'm just telling if in any Olympiad, this notes can be also used for Olympiads. So integration of u into v, this is product rule. So it just simply says that this is u. My mistake. This is u, not v. So it is says that first term multiplied by integration of second term, this whole term is known as v1, and minus u dash times integration v1, now integration of this term, and now this term is known as v2, and similarly the process goes on. But the process not long very much. But if mostly in second or third term it becomes 0. If you don't understand, then let it be. um, See, if a function is there, see, suppose fx is there, and you integrate fx, you get another function that is gx plus some constant c, and now you replace that fx by ax plus b, x by ax plus b, and now you integrate. Now you will get the same function, that is g similar, but x will be replaced by ax plus b. That's the difference, and the differentiation of ax plus b will be divided, that is a. Note one more important is that differentiation of a raised to the power x is ax ln a, but integration of a raised to the power x dx is ax divided by ln a. Of course, log with base e. uh, this is just a miscellaneous property. If you can remember, good. Not remember, no problem. That integration of integration of function raised to the power n multiplied by differentiation of function, the whole term integration will be that function raised to the power n plus 1 divided by n plus 1. Just treat that function like a x, and then integrate it. Uh, this is similar that integration of f dash x upon f x raised to the power n. The same here, but the order is changed, that fx 1 minus n divided by 1 minus n. Uh, this is also miscellaneous, not very much useful. You want to remember, you can remember that integration of 1 upon x into x raised to the power n plus 1, its integration is minus 1 upon x ln 1 plus 1 upon x raised to the power n. Now the most important rule, this product rule, it is for uh, this product rule is for, if you don't understand this rule is of course for, means not required now, I just told it. This product rule is very much important, this product rule, that integration of uv, it is, this rule is derived from that rule actually. And you have to follow islet rule also here, that first for taking u and v, you will, how will you decide that priority of u and v, which to take u and v. So this is rule, this islet is for you, that give first preference for you is that inverse function, second function is logarithmic function, third is algebraic, fourth is trigonometric, and fourth is exponential. Whenever you see exponential function, make it as v, as exponential functions are most easy, therefore it easy to integrate, therefore it is kept in the last priority for choosing u. And we will see the formula that first u times integration of v dx minus integration of du by dx multiplied by integration of v. Similar formula is that now seeing the next, this is very much useful. If you will keep if you will in exam you will go for derivation, it will take very much time. I will say just remember that integration of tan x is log of secant x. And one more thing I am saying is that everything in log has a mod. Here also you will see mod. Then integration of cot of dx is log of sin x. Integration of secant x is log of secant x plus tan x x. Please don't confuse it with secant square x, or when the answer comes second, don't confuse it with that. That secant x dot tan x integration is secant x. This is different, that is different. Secant x has many form, that integration of secant x is log of secant x plus tan x, integration of secant x is log of tan of pi by 4 plus x by 2, and other is that integration of secant x is ln of cot of pi by 4 minus ln x. This can be derived by that tan is equal to 1 upon cot, so that can be done, but you remember these two properties. The second text, this are used very much, and if you remember this also, it is easy. From here you can derive this also, but it is easy, that good if you remember that. Integration of now this is another most common use function, that 1 upon root x. You just remember that its integration is 2 root x. Now we will discuss some corollary functions. Corollary functions are functions which makes our life easy literally. That integration of f dash, whenever you see integration of f dash x divided by fx, its integration is just simply log of fx. This property is used very much. This property literally used very much, that integration of f dash x divided by fx is log of fx. This is another property, that integration of f dash x divided by root of fx its integration is twice of root fx. So we discussed the integration of secant x. Similarly, the integration of cosec x is important, that minus ln, that is log of cosec x plus cot x, and all is in mod. See here, I also write the mod. Ln of cosec x minus cot x and ln of tan x by 2. That This two, you just remember out of these two anyone, that as you know that cosec square minus cot square is equal to 1, so that can be derived. And the third one is the important, that ln is equal to tan x by 2. I am just sorry that it is getting smaller in between. Now we will discuss some types of specific integration, that uh, if integration dx upon root of a square minus x square, you will see that if in place of a there comes 1, then it becomes sine inverse x integration. Now in place of 1 you have to just put a and divided by a. So the integration of root 1 upon root of a square minus x square is sine inverse of x by a. Then this integration of sine inverse of a, this integration and this integration are very much used. Integration of dx a square plus x square is equal to 1 upon a tan inverse of x by a. These two integrations are very much used, you remember. These integrations are also used, that integration of dx upon root of x square plus a square is equal to ln of x plus root of x square plus a square. Then on fourth number is integration of dx root x square upon x square minus a square is equal to ln of x plus root of x square plus a square. Then integration of dx divided by x square minus a square is equal to 1 upon 2a ln of x minus a upon x plus a. These five properties are very much important, very much important. It is frequently used in the questions. Another most This is for the perspective of JEE Advance and Olympiads, that integration of secant cube x, that is mostly asked in JEE Advance, not for mains and MSCT purpose, but for JEE Advance and Olympiad uh, questions, that integration of secant cube x is secant into tan x divided by 2 plus half of ln of secant x plus tan x. And in some case they also ask you the integration of course, they give integration of 1 upon secant cube x, then use the integration of cos cube x. uh, Now type 2, all, see here, you see that all are in denominator and here all are in numerator. That integration of root of a square minus x square dx are x times a square minus x square by 2 plus a square by 2 sine inverse a by a x by a. Integration of root of a square plus x square is equal to half of x root a square plus x square plus a square by 2 ln of x square plus a square by plus x plus a square. See, you will just see that we will just replace plus by minus, but huge difference comes here. Sine function come here, logarithmic functions comes. These two, I am sorry, just a minute. Coming back to our, that integration of root of x square minus a square is equal to x times root of x square minus a square by 2 minus a square by 2 ln of x plus x square minus a square. All the plus sign is replaced by minus sign, just simply, except here this. Now type 3 is that integration of inverse functions. If you learn the integration of inverse function, it will save your time very much. That integration of sine inverse x is x times sine inverse x plus root of 1 minus x square. Then integration of cos inverse x is equal to x times cos inverse x minus root of 1 minus x square. When I used to study, how I remember was that integration of sine inverse x is equal to just write x into sine inverse x plus 1 upon differentiation of sine inverse x. You will see the same for cos and sine. It's just a remember technique, it is not the actual method. Just remember technique. Then next is integration of tan inverse x is equal to x times tan inverse x minus half of ln 1 plus x square. Then integration of cot inverse x is equal to x times cot inverse x plus half of ln 1 plus x square. Integration of secant inverse x is equal to x times secant inverse x minus ln of x plus root x square minus 1. Integration of cosec inverse x is equal to x times cosec inverse x plus half of ln x plus root of x square minus 1. Now for the type 4, and type 4, this and this are not very much used, but sometimes these questions are used in Jee Mains and Jee Advance. That integration of e raised to the power ax multiplied by sine of bx dx. Then its integration is e raised to the power ax divided by a square plus b square multiplied by square bracket a times sine bx minus b times cos bx. And similar for integration of e raised to the power, this type 4 is not for Jee Mains and MSCT. And inverse function integration is also not for Jee Mains, it is for Jee Advance. E raised to the power ax cos of bx dx, its integration is e raised to the power ax divided by a square plus b square multiplied by a times cos bx plus b times sin bx. See here, not a such major difference. Minor difference is that in upper part a times sine minus b times cos, and in a lower cos formula, that is a times cos plus b times sine. This is just a shortcut trick. I have found many times it comes in the paper. So in one book I have find this expression, that integration of but this is for definite integration, not for indefinite integration. This part must have been come in definite integration. That uh, integration of a raised to the power integration a to b fx dx, that its range will be that difference of that limit multiplied by lower put means f of that lower limit, that b minus a f of a is the minimum value, and the maximum value is b minus a f of b. Now this is uh, that if both the terms sine raised to the power of something and cos raised to the power of something comes, that integration of sine raised to the power mx dot integration of dot cos nx, sorry, integration. So if n is odd, then n is odd and m is um, any value, then put sin x is equal to t, and if m is odd, then put cos x is equal to t. If both m and n are odd, then put sin x is equal to t or cos x is equal to t. If m and both m and are even, higher power then even, then higher power, both out of which m or n, which is higher power, convert to higher angle, then integrate. And if m plus n belongs to negative even integer, then first arrange them and then put tan x is equal to t. See, here I said second cube integration, and here cos cos cube integration. Now, other part is that integration of ln of x. Integration of ln of x is x times ln x minus x. You just simply remember that x multiplied by ln x minus 1 brackets. Integration of ln x is very much useful. We can directly solve many questions by if we know the integration of ln x. Then this corollary is repeated. I told it upper. Then other corollary, some extra corollary are written here, that integration of f dash x upon fx is log of fx. Then other is integration of f dash x plus x times f dash x, we will get x times fx. Then integration of suppose any function is there having exponential functions, and multiplied by that functions, you see not, it will be not directly visible, you by manipulating or making some changes, or directly you observe that exponential function multiplied by some functions multiplied by some differentiation of that function will be e raised to the power fx, sorry, e raised to the power x multiplied by fx. This integration of sine square x, you just remember integration of sine square x and integration of tan square x. That is easy, as integration of sine square x is equal to x by 2 minus sine 2x by 4. Integration of cos square x is equal to x by 2 plus sine 2x by 4. For cos square x, you can just write 1 minus sine square x. Then integration of tan square x is equal to tan x minus x. If you just simply remember sine square x by manipulating uh, other, you can find tan square x also. And log integration of log square is not needed. I have just written for Jee Advance and Olympiad students, that x times log x square plus 2 log x plus 2. Then some of the standard substitutions. First is that mm, if our question contains the terms like x square plus a or x square plus a square, then put x is equal to a tan theta or x is equal to a cot theta. Then if our terms contains x square minus a square or root of x square minus a square, then put x is equal to a sec theta or a cosec theta. Then a square minus x square or root of a square minus x square, then put x is equal to a sin theta or x is equal to a cos theta. If now the second is that if both root of a plus x and a minus x are present, then put x is equal to a cos twice of theta. And then root of x minus a and b minus x, or root of x minus a divided by b minus x, then put a x is equal to a cos 2 theta plus b sin theta. This here, this is 2 theta actually. That is 2 theta. Next is that if the question is that root of x minus a multiplied by root of x minus b, or root of x minus a divided by x minus b, then simply put x is equal to a secant square theta minus b tan square theta. Type 4, um, that if the question is that root of x square plus a square plus minus xn, or plus minus for both the side, raised to the power n, then put both, in both case put them as t. Now some other types of type 1, this is different, this is different. Now if you got the question that most question, first of all I would tell you to that most question would not be in the form of indefinite integration. That in objective paper indefinite integration, in subjective paper indefinite integration has many answers. We can take many substitutions for there. So most probably questions will be objective based questions. Type 1 is that if we have to integrate dx upon a plus b sine square theta, or dx upon a plus b cos square theta, or we have to integrate dx upon a sine square theta plus b cos square theta plus c times sine theta cos theta plus d. Then divide numerator and denominator by sine square theta or cos square theta, or multiply by secant square theta. Then put tan x is equal to t, and second, and if you put tan x is equal to t, then just replace that dx and dt terms, that secant square dx is equal to dt. Type 2. Now type 2, if your functions is in the form of integration of 1 upon a sine theta plus b, 1 upon a sine x plus b cos x plus c, or integration of dx upon a sine x plus b cos x, or integration of 1 upon a plus b sin x, or integration of 1 upon a plus b cos x. Then put x is equal to 2 tan x by 2 divided by 1 plus tan square x by 2. That is, you will see this formula is for the twice angle of sine theta, and this formula cos x is equal to 1 minus tan square x by 2 plus tan square x by 2 divided by 1 plus tan square x by 2. That is for cos 2x formula. We have just replaced x by 2x by x and x by 2. And after this, put 1 plus tan square x by 2 as secant square x by 2. Then take tan x by 2 as t, and then differentiate and integrate. Type 3. Type 3 is that if you have to integrate the terms like a sine x plus b cos x plus c divided by l sine x plus m cos x plus n dx, then this is used most commonly as if it looks difficult but it is easy, that you have to just write numerator in the form of denominator. That numerator is equal to some a times denominator plus b times differentiation of denominator plus c. It looks difficult, but when actually question comes, it is easy, and this is important also. Now type 4. And type 4 is quite complicated, that if denominator contain a sine 2x or root of b plus sine 2x, or numerator contains cos square cos x minus sine x, or cos x plus sine x, um, or cos x plus sine x, or cos x minus sine x, or a plus sine x, means vice versa. Then simply put, this is also important. Then put sine 2x is equal to sine square x, put equal to sine x plus cos x whole square minus 1, or sine 2x is equal to 1 minus sine x minus cos x whole square. And which of both you have to use, you will get with that practice. And type 5, for type 5, um, this is similar to above question. Above we have seen that integration of sine raised to the power mx multiplied by uh, integration of sine raised to the power mx multiplied by cos raised to the power nx. Then case 1 is that at least m and n is odd integer, at least both can be there, single can be there. Then put sin x is equal to sin x or cos x is equal to t. And the second condition is that both m and n are even, then play with cos, put cos square is equal to 1 plus cos 2x by 2, and sine square x is equal to 1 minus cos 2x by 2. Case 3 is that if m and n are negative integers, then simply put tan x is equal to t, and then uh, differentiate that as you would know need dx term. Mm, Now another is integration of rational functions. Integration of rational functions, suppose some polynomial function in numerator, some polynomial function in denominator. Then method is partial fraction. We have to make numerator as factors of denominators. Then case 1 is that when the degree of denominator is greater than the degree of numerator. In that also a part is that when denominator has non-linear factors. So just simply write nx upon dx as a upon x minus a1 plus a2 upon x minus a2 dot dot dot, and just compare then and find a1 a2 a2, and your question will be easily solved. Then other is that when they have repetitive factors, denominator has repetitive factors, that x minus a raised to the power k, x minus a1, x minus a2. Then numerator upon denominator would be similar, but we have to add some more term, that a1 upon x minus a1 plus a2 upon x minus a whole square, a times still some a x minus a raised to the power k, and then other factor, that b upon x minus a1. This looks a little bit complicated, but this and this are very much important. These questions frequently asked in the exam. They look like, oh, such a complicated formula, but if you practice some questions, and you did not need to remember the formula. By the seeing and just uh, applying it, you will easily get the answer. Then case 2, if the degree of numerator is greater than degree of denominator, then you have to just simply divide that numerator. Means first you have to divide that question plus remainder upon that something. Then if you will get some qx terms and plus some rx upon dx terms. So you then this qx can now be easily integrated, that it would be one line integration. And for this rx upon dx, that is remainder upon denominator, you follow uppercase. So this is quite lengthy. Now definite integration, this lecture is quite I have seen that this lecture now have crossed roughly 38 minutes. So for today this much only. For definite integration, this definite integration we will do in next lecture. So for today, thank you. And if any queries you have, any suggestions you have, please write in the comment. Thank you, and may your day be good.